So now, today, as in the series of this DWSIM simulations, we have learned how to simulate a distillation column. But in today's tutorial, we are gonna simulate again the distillation column, but with the ChemSep package. Why I am gonna use ChemSep package? Because this column, the ChemSep column, contains few other unit operations also that we are going to learn how to simulate later in this tutorial series. So for today, our objective is to simulate a distillation column in the ChemSet, and what we are going to do, we are going to use the previously available data that is from the different simulation that is with us to simulate the unit operation in ChemSet. For this simulation, what we are going to use methanol and water mixture, where water and methanol will be at the flow rate of 100 kg per hour at 25 degrees C centigrade and 1 bar pressure, where the mole fraction of water in the feed is 0.6 and the boiling point of water is 100 degrees centigrade and methanol is 65 degrees centigrade. You might see these two new words, heavy key and low key. So heavy key is the component who have a high boiling point or which will not going to which is less volatile compared to the other component in the mixture. What means less volatile? Once you are boiling the mixture, the component that will come out most in the vapor phase is the low key component and is the high volatile component. So this is our distillation column simulation tutorial. So let's now jump to the DWSIM before wasting any time. So from here I will open the DWSIM. Now what will I do? I will go to the new steady state simulation. Here I will click on next. I will add water by typing water in search bar. Now I also need to add methanol because this is the initial part of the simulation setup. Now I will click on next. Now it is asking for the property package. So I am going to choose the Rawls law. Here you can see only few of them are marked as green, so you can use any of them. I am going to use Raoult's law because it is mostly gonna work for me. Now I am gonna go to the next. I will choose C5 because I have temperature in centigrade and pressure in bar, flow rate in kg per hour. That's are my requirement, which are made by this system of units. I will click on next. No need to bother about this. Click on finish. Now use this wizard. Now what I will do, I will go to the columns. Here you can see ChemSep column. I am gonna add this column. There is a window that will open. It will say unit type. I am gonna change it to the distillation column. Okay. And yeah, here you can see the list of unit operation that it can do. I am gonna it can do extractive distillation, azeotropic distillation, simple distillation, and many things. I am gonna use the simple distillation. Here the number of stages. I am gonna make it to the 11 because I know it earlier. Now I will click on OK. You can see its name changed to the distillation column. Here this ChemSep distillation column setup will open. Here on Capton you need to expose the energy ports also. Then after that you click on this next button, it will guide you to each thing. Here you can see T and B, the boiling points. Basically water you can see it is 100 degrees centigrade and here it is 64, so 64 plus 273, this is the value in Kelvin. Now here you can see feed. If you want at feed at 5th stage you can change it to 5th. You also change it to 4th, but as we know it will be better to have on 6th. We are going to introduce our feed at 6th. Now you need to click on next, next, next. Now it will ask for condenser pressure, column pressure. As we are considering zero pressure drop in a column, we will keep them as safe, no column heat loss. Now here it comes the efficiency of stage. Sometimes in the real life we know the efficiency of stage is not 100%. So we are not going to take it as 1, it might be 0.9, 0.8 or some other number. I will click on next. Here I see the top specification. There are many things are given, but I will choose the reflux ratio and I will make it as 0.4. Now what will happen? I will next click on next. Next. How I come to the 0.4? This is like 0.4. You can say it comes to me through intuition, or you can guess this value and later you can modify it if you don't get the desired separation. Now I will click on next, 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 and here you can set the solver. After everything is set up, you just need to click on save, close this. Now what you need to do, double click on this, make it as a distillation column. It will be now modified. Here, create and generate, and outlet, create and generate. Similarly, bottom product, create and generate. Energy for condenser heat duty, create and generate. All this create and generate. Now, what next move? To rename these streams. So I will rename it as a condenser duty, and then again rename it as a reboiler duty. Why we need to rename? Because this will help us to understand this. We are not doing just the simulation. We also want to understand the chemical process behind it. So renaming it will help us to better understand the things how the simulation is. This will be the top product, and I am expecting methanol only. So I will name it as what I am expecting and what I will get will be the two different things. You can say it is happens in life, but yeah, it is a different thing. So now I add water to it. It should be it will be not a bottom product, and it will be water. And this I will mark as a feed. Now what I will do with feed, I know it has 1 bar and 100 per hour. Next I will do start the calculations as soon as I hit enter. I also need to modify the mole fractions. I will wait for this to run, and then I will modify my things. Now you can see started calculating. Okay, okay. So now you can see, oh, there is no warning, no error, everything is calculated, but there is one error only. I need to make the mole fraction of water 0.6 and that of 0.4, and now I accept it, and now it will rerun again. Uh, yeah. Now what I will do, which we usually do to better visualize these things, I will add the property tables. I will add two property tables, or let's say three, because I also want to understand the feed. I just want to see on the feed. So, okay, property table, condenser duty, water duty. One I need to modify. Sorry, I forgot to rename it as a feed. I need to enter. Now, now I will double click it. I want feed, temperature, mass flow, molar flow, and I want molar fraction, mixture water. These are things I want. I will get these things. You can see. Now I will double click on this. Will add bottom product first. Sorry, top product, because it is near to the top. Temperature I want, pressure I want, mass flow I want, molar flow I want, and then I will go to the, here you can see molar fraction. Sorry, molar fraction, mixture water, and then I will add molar fraction mixture methanol. These three things I want. You can see here it is enriched in methanol, but it is not completely contain the methanol. Similarly, the bottom products, if I talk about bottom product, temperature, pressure, mass flow, molar flow, these three things I want. and then the same thing I will want here, the molar fraction of water and the molar fraction of mixture methanol. You see, now you can literally see it is enriched in water, but what is happening, uh, I am not getting the same amount of pure methanol here. So what I will do, I will go to the column, open the cap open object editor. Here I in specifications or operations, you click on next, column specs. Here the reflex ratio is given. I will increase it to 0.6, and what I will do, I am gonna save it, and yes, then I am gonna rerun it. Now you see. Okay. At point 0.6, I am close to 0.8. What I will do, I will again open it and go to the column specs, make it 0.8. Now I will click on save. It's saved. Now I will run it again. Correct. So you can see here, whatever the mole fraction I am using, whatever the reflux ratio I am using, I am not getting the desired separation. So the next thing to play is the number of stages. What I will do now, I will allow more number of stages, which will allow more time for separation in this column, and then will help us to achieve the desired conversion. So I will go to the operation. Here I will add number of stages to 15 and feed as usual to the middle. I will make it 7. I will make it 8 because it is count from the top. So what will now happen, I will save it, cancel it. Now what I will do, I will solve. Okay. Now as the result are not moving, what this column will help us to visualize. Now I will directly go to the MacCap hill, and here I can see. Here if you see, here I am operating on this, and then I am moving to the another operating. Here these two are the operating line. This is the equilibrium between these two. So now what I exactly want to do, and here this is our feed concentration. If you see here, our feed is there, and from there this is the feed point. Here my column changed to the different thing. So you can see here I am just losing the this stage. If I want to achieve here, I think I need to make this line more steep, and that will be done by only the uh, reflux ratio. So while just make it to save, solve it, you can see it is slightly increasing. That means whatever we are doing, this mixture is attaining the separation. Next thing, we are gonna learn how to separate this mixture more using the different simulation techniques, because you can see here how much I am increasing the reflux ratio. It is just slightly increasing the molar fraction, but here we can get pure of water. But here we are getting little bit of water because uh, at the top also in these pressure conditions we might get much more of water. But second thing I can do, I might operate my column at higher pressure, which are the different things that we can use. But the sole purpose of this video to learn how to simulate a ChemSep operation for the distillation column. So this is just about the setting up. Now In the next videos, we will learn how to get these parameters, how to optimize it. Those things will come later. But this is just the intro video to the ChemSep call.